OSI ISO model divides on 7 layers. The easy way to remember all the layers is phrase: all people seem to need data processing. All people seem to need data processing. APSTNDP. So all translates to application, people, presentation, SIM, session, to transport, need, network, data, data link, processing, physical. So we number the layers from bottom to top. So physical layer is the first layer. However, usually they are presented from the top. So application layer is layer that concerns with the end user. Protocols in this layer are used by end user applications like browsers. Chrome, for example, uses HTTP protocol to access the websites. SMTP is used by email. DHCP is for deciding IP addresses, assigning IP addresses. FTP for file transfer. Telnet for shell control. It's virtual terminal protocol. POP3 has something to do with email again. Presentation layer, it's the layer concerned with encryption and decryption, as well as compressing. It converts binary, it converts back and forth binary and presentation format. So for example, text, images become binary, and protocols used in this layer are MIME, MIME, SSL, TLS, XDR. MIME, for example, is protocol used to recognize and encode different types of file, binary to file, exactly what I was talking about. Session layer creates a session between the source and destination nodes and terminates session completion of the communication process. Protocols in session layer are PPTP, SAP, L2TP, and NetBIOS. NetBIOS concerns with starting and terminating sessions. Transport layer is the layer that works on two determined communication modes: connection oriented and connectionless. It uses ports to determine addressee node. The PDU in this layer are called segments. The standard protocols used in transport layer are TCP and UDP. They are most popular. However, there are some different: SPX, DCCP, and SCTP. The most important ones are TCP and UDP. TCP is used where the confirmation of each packet being delivered has to occur in case of sending files over the internet or visiting websites, which is actually just downloading the file, HTML file in this case. UDP, on the contrary, is faster than this TCP, but it doesn't involve sending feedback about confirmations about whether segments has been received on the other end. Network layer, the next layer, is the network is the layer concerned with a routing between computers, between networks. That's why the word network is appropriate. Routing between networks. Okay. The PDU, protocol data unit, bears the name packet. Protocols used in network layer are IP, IPv4, or IPv6, IPX, AppleTalk, ICMP. ICMP is used for pinging, IPsec, and IGMP. The next layer is data link layer. This layer is used extensively in switches. On this layer, protocol data unit, PDU, is called frame. The easy way to remember the name frame is because this is the only layer that actually encapsulates data around like a frame, because it has a footer that starts and ends the frame. So there is a header added at the top and footer added at the end. The protocols used in data link layer involve ARP, address resolution protocol, CSLIP, HDLC, IEE 802.3, PPP, X25, SLIP, ATM, SDLS, and PLIP. The last layer, or the first layer, it's physical layer. It concerns with cables, ports, electromagnetic waves, means of distributing data around the network in actual physical world. The protocol data unit name for it is bit or symbol. The protocols used in physical layer are Bluetooth, PON, OTN, DSL. It has been used in when you use, for example, old BT routers. They use phone line connection. So DSL is for phone line connection. ADSL. IEEE 802.11, which is Ethernet. IEEE 802.3, which is Wi-Fi. L431 or TIA 449. These are the protocols used in physical layer. Looking at TCP IP model, TCP IP model has only 4 layers: application, transport, internet, and network access. It's ATIN, ATIN. Application layer gathers together, corresponds to application presentation and session layer, because TCP IP is mostly used by networking workers which are involved with setting up routers. So application is kind of, let's say, not important. All the stuff that is happening over there is DHCP, so IP addressing, everything which is basically needs some coding and yeah, it's just matter of application. It's not important to differentiate between these layers. So application layer again is concerned with all the complicated stuff that is not networking itself. Transport layer is basically one-to-one transport layer, so it concerns with ports and TCP IP TCP UDP protocols. It's concerned only between passing the data from one to the other node. Internet layer is the IP layer, so this is where the routing happens, and routers are on the layer 3 they are called, but in this is layer 2. And network access layer encompasses both data link and physical layer, because actually switches need to know both of this families of protocols. So again, TCP/IP model has application, which encapsulates application, presentation, and session layers from OSI model. Transport layer is just OSI transport layer. Internet layer is the network layer, and network access layer, so it's where do we accessing the network from physical world, and it encapsulates data link and physical layers. So again, all people seem to need data processing: application, presentation, session, transport, network, data link, physical layer. Application uses HTTP, SMTP, DHCP, FTP, Telnet, POP3. Presentation layer uses MIME, MIME. Another protocol is SSL, TLS, XDR. Session layer uses protocols such as PPTP, NetBIOS, SAP. Transport layer uses TCP, UDP. There are two most important protocols in transport layer. Network layer uses IP, IPv4, IPv6. There is some alternative Apple Talk, ICMP as well for pinging, because it uses IP addresses. Data link layer uses frames employing protocols such as ARP, Address Resolution Protocol, PPP, and physical layer uses Bluetooth, Ethernet, known as IEEE 802.11, Wi-Fi, Ethernet, Wi-Fi, it's 802.3. The protocol data unit, PDU, for application it's just layer 7 header, for presentations that's level 6 header, for session is just level 5 header, but for transport we are calling the PDUs segments, because that's where the data is divided into segments. Network layer uses packet PDUs. Every packet has a IP address, so they are divided and they can be like separately send transport layer concerns with are they all has been sent and confirmed, but network layer just concerns does one packet is properly routed to the other computer. Data link layer uses frames, PDUs. So frames are the one which encapsulate data around. So from the start they have header and they have footer. There is a as well on this layer you have the bit that checks consistency of the data. There is another thing in physical layer you have bits or symbols, but there is another thing about the presentation layer. I think it uses checksums. Yeah, checksum thing. Okay, that's it.